This lesson will be an extension of the previous one, much like those before it, building upon our knowledge we've already built in Algebra 1. We'll be solving equations with variables on both sides. Let me show you what that looks like. Then I want you to pause the video and give it a good think on how you would solve this equation. So we have 2x plus 3 equals x plus 7. Pause the video, think about it, try some stuff, and then we'll resume. All right, so the rules stay the same. The big idea stays the same. And that is that we want to isolate the variable on one side. So we're going to approach it like our previous problems. Let's do the addition and subtraction first. That would leave 2x equals x plus 7. Now there's a next step we can take that may not be obvious to you, and that is that we can subtract an x from both sides. And what we would end up with is x equals, 7 minus 3 certainly is not 7, it's 4. So that would leave us with x equals 4. Okay, if there's a disconnect there, why was I able to go from 2x equals x plus 4? Why was I able to subtract x from both sides? If there's a disconnect there, that's because these two expressions are equal. X plus x is equal to 2x because a multiplication is just repeated addition. Hopefully that makes it clear to why we can subtract an x from both sides and get x equals 4. Okay? So, as we just discussed, the goal is still to isolate the variables on one side. So let's work through another example. 3x plus 4 equals x plus 10. Now, this is where approaching these problems correctly or in the most efficient way becomes more and more important. If you were to go about and kind of, geez, these are some ugly plus signs. If you were to just go about and just go ahead and let's say do something that you shouldn't do, it's not the best thing to do that would work, like, I don't know, divide both sides by 3, divide everything in both sides by 3, you would end up with an equation that's really hard to solve. So that's why when we see this, we think about it. We realize that our best course of action is to subtract 4 from both sides to get 3x equals x plus 6. And we now know that we can subtract an x. We can subtract an x to get 2x equals 6. And as we learned in previous videos, now it's a one-step equation. We divide both sides by 2, and we get x equals 3, which would be our final answer. So we can also do the same thing with subtraction problems, like 5y minus 2 equals 2y plus 7. Okay, so this may give you pause. I have a subtraction on one side and addition on the other side. What do I do? What do I do? Well, what you do is remember the big idea. We want to isolate the variables on one side. So we will add 2 to both sides, add 2 to both sides, and get 9. Carry down the 2y, so it's 2y plus 9 equals 5y. And we're going to subtract 2y from both sides. What that will do is cancel these two out. We'll subtract 2y from this side, and we'll get 3y equals 9. We'll divide that by 3, and we will get y equals 3. There's a couple of examples for you. Now, I have to talk to you about special outcomes. There's a few special outcomes that can occur. Actually, let's go this way. Let's pull this up and we'll go special outcomes. Special outcomes. Once you're doing equations with variables on both sides, you come into the situation where you sometimes have special outcomes. So these are the possible results you can have. You could have, let's see, you could have x equals a number. Okay, that's what we've seen a lot of now. X equals a number, any number. What I'm introducing you to is possible results and special incomes. And when you have x equals a number, like we've seen again and again, what you have is one solution. There's one number to rule them all. There's one number that can fulfill the equation you were given. This is the one we have all of our experience with in green. But there's actually other outcomes when you have variables on both sides, such as 0x equals a number, and let me clarify that. Let's say number greater than 0. Okay, a number greater than 0. Number greater than 0. So think about this. When 0 times x, when you get that solution, well, anything times 0 is 0. So if you get 0x equals a number that is not 0, well, you've ran into one of the special results or outcomes that is no solutions. This is just going to be an intro to this. And we'll go much more in depth on this later on, but I just want you to be aware of them. When you get 0x equals a number, that means there's no solutions. And there's one final special result that you may get, and that is 0x equals 0. All right, when we see that, that means that 0x equals 0. Well, any value of x times 0 would equal 0. If x was 100, it would equal 0. What that means is you have infinite solutions. Any value will satisfy this equation. Infinite solutions. This is all things you're going to need to know as you proceed in your algebra journey. I simply wanted to introduce them to you here. You won't use them in the practice set, but it will be coming soon. We'll go much more in depth on that. So just as a final review, if x equals a number, we have one solution. That's what we've worked with so much. If 0x equals a number greater than 0, there are no solutions to that. equation. No number can fill the place of x and satisfy it. And finally, when you have 0 times x equals 0, you have infinite solutions. Any old number will do. All right, let's get into a practice set now. All right, here's the practice set for you to work through solving some equations with variables on both sides. Go ahead, work through these, then I'll work through them myself. All right, let's see here. Let's start with green, top left. 2x plus 5 equals x plus 9. All right, as we have learned, we're going to approach this with addition and subtraction first to get x equals 2x. Sorry, to get x plus 4 equals 2x. X plus 4. Then we can subtract an x from both sides to get x equals 4. That is our final answer. We will move down to orange. 4y minus 3 equals 2y plus 5. Let's go ahead and add 5 to both sides. Add 5 to both sides. And let's go ahead and leave it like that. I'll make sure I use my space adequately and also back up. Thinking about space, not math. So we're going to add 3 to both sides. 2y plus 5. Is that right? 2y plus 5, yeah. So we're going to add 3 to both sides. Add 3 to both sides. Then we get 4y equals 2y plus 8. 2y plus 8. We're going to subtract 2 y's from both sides. And we're going to get 2y equals 8. We're going to divide both of these by 2. Divide by 2. And we get y equals 4. That's our final answer. Okay, what do we have here? Let's go ahead. We're going to switch it up a little bit here. Let's subtract the variable first. Let's get a little different. We get 2a plus 6. And we get 10 on this side, and that's an equation. Now we'll subtract 6 from both sides, and we get 2a equals 4. We divide by 2, and we'll write it over here, a equals 2. All right. And for the last one here, how should we approach this one? We could do addition or subtraction. It could be either way. Let's go back to the known method, the one we've done again and again. We get 7x equals 3x plus 16. We will subtract 3x from both sides, and we'll get 4x equals 16. We're going to divide both sides by 4. 4x, divide both sides by 4, divide by 4, and we'll get x equals 4. And that's our final answer there. That was the practice set. It looks like as we go along further in this journey together, I'm going to need a bigger board or a new system to present practice problems to you.